Okay, welcome everyone to this webinar that we're having today. And let me start. I just need to switch my screens here. So this is the fourth episode that we have with this format, our OSS Power-Ups. Today we have Silk.net here with Kai and Dylan. And this is all about Silk.net here. Now my tablet started playing as well. So this is all about .NET open source projects and the .NET community. And first things first, also since this is the first time we're streaming on the .NET Foundation channel as well, if you have any questions, feel free to post them in the chat down below or on the right. This will also be recorded, so if at any point you have to drop out, feel free to continue watching afterwards. And again, since this is the first time we're having this on the .NET Foundation channel, I will also share a couple of information on how this came about. So if we look at open source and particularly the .NET ecosystem and open source there, we see that lots of maintainers freely share their great work with the public, and organizations often benefit. Let me also disable notifications, my mistake. Organizations widely benefit from that and also save own investments, of course. However, the contributions back are probably more insufficient. So if you're on Twitter, for instance, or read a couple of blog posts, you may know about Aaron Stannard, who's a great voice for .NET open source. And if you follow those blog posts, then you can clearly understand that there is a sustainability problem in the .NET open source ecosystem. And maintainers might receive a lot of popularity through their great work, of course, but with that also comes a lot more responsibility. So they're expected to triage issues and sometimes even get rude comments, of course, unfortunately. They're required to update their documentation, which we as consumers sometimes not even read, pay for hosting services, etc. And the real tragedy here is if a project gets discontinued due to burnout, for instance, too, it would affect the whole community. So no one really wins here. And that's a tragedy if those creative minds get left behind. So with that, we asked ourselves at the JetBrains team, .NET advocacy in particular, what can we do about it? Of course, there's also a .NET Foundation, which is a great effort, I have to say. But we tried to come up with something out from our own resources, let's say. And with that, we want to have every month, probably, that's the plan at least, we want to have a new project that gets our OSS Power-Ups treatment. And the question is, what does that mean? So the first of all, we would like to sponsor the maintainers with $100 per month for a full year. The second is we want to give those projects and their maintainers a platform to talk about their project, of course, and make everyone aware that they're open to receive sponsorships and what kind of ways to contribute to the project exists. And the third one, and this is really the fun part here also for our whole advocacy team, we would like to share our personal strengths, which are very diverse. So Martin, for instance, knows a lot about .NET or memory profiling and etc. Khalid, if you know him, he's a mastermind with graphical content. Always like to see his tweets also. And we can, of course, also help with CI pipeline, including signing of assemblies. And the real fun part is the last one I have here, which are plugins. So dedicated plugins that help users of the individual library to work better with that particular library. And that is actually also something we talk about today. But with that said, and I'm a little bit lost at my window management. With that said, I will bring in Kai and Dylan today. And let's also run my screen for a moment. And welcome to you too.
Hi.
Kai is muted, yeah. Okay, cool. I hope you're both doing great. I'm really excited, I have to say, about this webinar today because it contains lots of stuff that also touches my personal preferences. So I'm really excited. But let's talk about you. So you two are maintaining Silk.net for how long, and how did you get to it, and what are you usually doing? And let's start with Dylan, let's say.
Yeah, so I originally started Silk.net. It was so I was maintaining another project at the time, and I found myself that this was another relatively large project, and I found myself limited by the massive overhead that it had in terms of well, if you've got lots of users who are expecting a consistent library, then well, you can't really make changes. So Silk.net is more a breakout project where we were able to break everything and not really have any repercussions. Of course, now it's a bit different that we have people following us. But yeah, so Silk.net, I've been maintaining it for around 2 years, which is the lifetime of the project. It's very new. And yeah, it's purely because I have a love of graphics, really. And yeah, I do stuff with Silk.net outside of just maintaining the library. I also help make games, and as well as I manage the Discord community for Silk.net as well, which is always fun to see what people are making with it.
Yeah, really cool. Kai, I know you joined a bit later. How did that came about?
So I joined about a year ago. It should be pretty much a year now, and I can't really say that I did a lot with graphics before then. I kind of looked for a good graphics library at the time, and I knew Dylan via the C# Discord, and kind of just joined Silk.net from there. Tried fiddling around with it a bit and trying to learn graphics, but kind of got distracted by contributing to it. And yeah, since then I'm been maintaining it.
Sounds really cool. So one thing, and I hope I'm allowed to say that, you're both really, really young compared to most of the maintainers I know. And basically, it's just a comment from myself. I think you're doing a great job. I mean, Silk.net has gained great popularity over that time. And I know, Kai, you're still a student. Dylan, I think too, but partly working, right?
Yes, yeah. I was originally when Silk.net started, I was doing education full time, but then then I dropped out and I'm only doing studying on the side now.
That sounds really cool. Okay, I think with that, I will leave the stage to you, and I think we add Kai's screen first. You ready, Kai?
Sure.
Yeah, so I added your screen, and let's learn a bit about Silk.net now.
All right, I'll do this intro bit. So Silk.net is so for this webinar, Silk.net is obviously has got a lot of advanced topics. It's got graphics, it's got high-grade GPU compute. Those are very complicated subjects that we're not even going to try and explain in this webinar. So what we're going to talk about is Silk.net's generation mechanism, which is well, it's quite vast. I've often joked that that Silk.net is just a big XML to C# converter, which it is, because if we go to the next slide, we have a lot of generative. Kai. Yeah, so yeah, we generate a lot of code. In fact, nearly 7 million lines of code of Silk.net is generated. Oh wait, no, I think that's a total number. But yeah, most of our code is generated. And in this webinar, we wanted to discuss how we facilitated that, what sort of dark secret C# language features that we are that we're using to facilitate that. But first of all, we should probably tell you what Silk.net is. And yeah, so if we go to the next slide. So Silk.net is a high-grade compute and graphic library. So what is that? It's a bindings library. So we don't do the actual compute. What we are doing with Silk.net is we're lifting C and C++ libraries, and we're bringing them to the C# level. And obviously, that doesn't always look the clean. You may have heard of unsafe code, which is all sorts of pointers and stuff. But that is done in the name of our next point, which is providing low overhead. So Silk.net tries to add as minimal overhead as possible. But at the same time, we want to be usable as well. So we do provide some C# helpers, just to make it more like the rest of your code will look and not completely all over the place and like you're just trying to use C++ and C#, because at that point, just use C++. But yeah, the aim of the project is to be a one-stop shop for anything .NET and GPU related, which means we're essentially trying to give you all the tools you could possibly need for your games applications, your game engines, your scientific visualizations, whatever you can make with a GPU. If it draws a triangle, we probably have something to help with that. So moving on, we do have a lot of APIs. So as I said before, we try to keep it as one-to-one as possible while also neatening it up a bit so it looks more C# and less C++. So yeah, we've got around 17 bindings at the moment, which is a lot. That's a lot of C APIs that we've tried to facilitate access to. But we also provide some high-level utility libraries for just to handle common things like cross-platform window creation, cross-platform inputs, so like your keyboards, your game controllers, and we've also got a maths library, which I'm sure Kai is looking very forward to talk about. But the importance of this project is mainly as it brings C# closer to the metal. Obviously, we all know GPUs are very, very fast, and you can do a lot of powerful things with them. And Silk.net's role is basically to facilitate that, so you can, you can do whatever you want with a GPU with Silk.net. And the reason why you'd want to use something like Silk.net over something like Unity is because we give you complete control. We don't try and hold your hands. That's the point of Silk.net. And because of that, you can get every nanosecond of performance you could possibly get out of a graphics application. And then the next slide. Sorry, I've just spoiled the next slide there. So if we move on again. So Silk.net, we do things a bit differently. So we have consistent monthly updates because, well, stuff has did. I'm sure you've all seen in the graphics industry, all the move to GTX, ray tracing, that graphics moves a lot and it moves fast. So what we need to do to help facilitate that is keep up. So what we do is we have consistent monthly updates. You can count on us the first Friday of every month having an update ready to go and with new functionality and whatever has changed in the libraries we provide, which yeah, helps us keep up. And one thing's important that we made important from the start, as I touched on at the beginning, is we're not afraid to rapidly develop the library in a very quick time frame. So it mainly so we can make changes to make the library better rather than worrying about the people who are kept behind. At the same time, so that does mean that you might be at risk of small breaks here and there. We try to minimize it as much as possible, but Silk.net is important because it keeps up with the times. It keeps up with the latest changes in graphics and compute. So if we move on, we're continuously improving. We're the first to adopt the new .NET and C# features, which is if there's something secret in the language that that we could get a couple of nanoseconds out of, then yes, we will use it. Of course, it means that there's a lot to Silk.net that you might not have used before. a lot of secret internals. We're going to touch on a couple of them in this webinar. Monthly updates, as I was saying, because, well, yeah, 1 month is all it takes to have a massive change in the libraries that we provide. And we need to keep that up to date, because you know, if our libraries that we bind to are changing all the time, then you can bet that our library consumers are wanting to change all the time as well and take advantage of these new features. And yeah, we've got a backing which is growing stronger by the day, obviously with the new OSS Power-Up, but also the .NET Foundation. So something that can't be said about other libraries is that you can count on us not dying tomorrow, which is very important, because as Matt touched on at the beginning of the webinar, sustainability is important with open source libraries. Okay, so next, back to this big figure. What the hell have we done to get such a high number? So we're actually going to touch on the less important, well, not less important, but less interesting bit of it at the moment, the manually written portion. So next up, yeah, we can see that only 118,000, well, I say only, 118,000 lines of manually written C# code. That is a lot, but it's not as much as the other millions of lines of code that our generators output. So let's have a look at this, the next slide. So as I mentioned earlier, we have a few high-level utilities which help you would help you cover the snags that you most commonly encounter when doing anything graphics, really. So windowing is the first one. So, well, I presume that a lot of you spend a lot of time with an operating system. You may notice that everything is in a window. It turns out that is a pain in the ass to get working cross-platform. So we really need to try and make that as easy as possible. Because, well, if .NET Core, it runs on Linux, macOS, and Windows. We also want to run in all of those places, but at the same time, we don't want our users to have to change all of their code to do that. Let's have a look at what this does. So next up, this is a code snippet of how you might open a window on just desktop. So this is using a library called glfw, which we use internally. Not all of the time, but we try, when we do use something different, we try to make it as seamless as possible. And on the next slide, you can see the difference it makes when you're using Silk.net's abstractions. It makes it a lot easier and a lot more C#-like, rather than all of these weird functions that don't really make sense. And yeah, you can it's much more easily integrated into any C# application if you have a more C# like abstraction that runs everywhere. So Silk.net windowing runs on Windows, Linux, macOS, and Android, and iOS, but we haven't quite got there yet. We're hoping with .NET 6 that we'll get there. And with input on the next slide, it's a similar scenario. There's a lot of stuff to do just to figure out whether the A button is pressed, which on a game controller, which is probably a bit more than you need. But if we go on the next slide as well, you can see that Silk.net makes it easier as well. So we have something that's called a input context, which you create when you first start up the window. And then it's as simple as just looping through the gamepad and checking if the A button is pressed, which is a lot more sane than having to get lots of different states, as you saw on the previous slide. So moving on, and I think I'm going to let Kai cover this next section, seeing as this is his area.
May I ask one question? We already have one. And the question is, what are the advantages of using this as opposed to something like OpenTK?
versus OpenTK. So one of the things is that we try to be as one-to-one as possible. Obviously, OpenTK has been a massive player in this industry, and I've actually worked on the OpenTK project as a precursor to Silk.net. One of the advantages of this is that, well, first of all, we have a lot more bindings. That's a given, but obviously not everyone's going to use every single library we provide. But second of all, is we're using a lot more modern C# features like source generators, which we're going to touch on, as well as we're trying to slowly vectorize our mass library so you can get an extra bit of nanoseconds performance in your code. But yeah, the main advantages is, well, I touched upon it before, is that it's the consistent monthly updates, and that's pretty much it. We're a lot more sustainable, and we're quick to move as well. So if something happens in the industry, you can count on us responding to it in the next monthly update, which we've seen with like ray tracing, which currently I think Silk.net is the only bindings library to provide ray tracing, but don't quote me on that because I don't actually know for sure.
I actually have one more question. So you say you're more up to date and you have basically push out regular updates. Do you have some kind of number? Like if you would think, you would check in your source code. I think you don't, as far as I know. But if it would happen, what is the amount of lines that get changed from one update to another? Can you put it in a number?
Oh man, so this is an interesting one because all of our code is generated, and if there's a lot of changes in the sources we generate our code from, the number could easily be in the tens or hundreds of thousands, which is a lot. And that's pushed to the repo as well. That's not even talking about the gremlins that go on behind the scenes that you don't see in the repo. So yeah, it can be a lot, but it is necessary to keep up to date.
Okay, so sounds good. Babe, of course, much better than handwritten, right? I can tell from experience.
Oh,
so
yes,
if you
of course.
anything, that's great. Okay, then
yeah, well, yeah, we wouldn't be talking it. We wouldn't be having a whole webinar around generated code if it wasn't a lot easier than writing each of these bindings by hand.
Yeah.
So yeah, Kai, I apologize. I stole your thunder a bit there. Back to you.
No problem. So Mars is still a part of the manually written code, and we used to use the system numerics Mars, which probably most C# users know. It's kind of the default in system, which classes like vector3 come from. But you have a couple more keys than are covered by system numerics, and namely the most important bit is that our Mars library is fully generic, because you don't always want to use floating point numbers. You sometimes want to use, an integer maybe in your shader or even your normal CPU code. And that's what we provide. We have all of our types fully generic, so you can tell us what type to use under the hood. And this isn't just integers and floats, but this also includes things like bytes and double size floating point numbers and similar things. But we also have some extra graphics APIs which you might need. System numerics already includes matrix 4x4 and matrix 3x2, but we also include kind of all of the other permutations from 4 to 2. So, for example, we also have a matrix 4x2. We have curve types, etc. So we just kind of expand on that idea and try to provide some more graphics-oriented API. So now I want to move on to the generated portion. First of all, SilkTouch, which generates about 5.5 million lines of code on every build of Silk.net, because it's a source generator. And you might have heard about source generators at the .NET days. The first day there was a talk about source generators, so if you care for that, do check that out. I'm just going to quickly say, source generators are basically something invoked by the compiler when you build the project. This doesn't really influence our users. It only really happens when we build Silk.net itself and is then packaged into the nugget, for example. But yeah, we use that, and we have replaced our old reflection-based generator about a year ago now, or at least we started replacing it about a year ago. And this basically brings the startup cost of Silk.net to almost zero. We of course still need to load the native library, for example, GL or whatever graphics you're using, but the function loading itself is very, very fast, and so startup time is very, very short. Being a source generator, we are on C# 9.0 anyways, and we can use some of its most intricate features. For example, this one. If you've seen this before, I'm quite impressed. I didn't before I researched into this, and this really is a valid C# type. And it's a function pointer, which is, as a C# user, you might sort of think of it like a delegate, like a func, if that's something you know, with the two parameters first, the int and the int pointer, and the return type at the end. And this is what we use to invoke C or C++ functions. Essentially, we load the pointer from native and cast it into something that looks like this. Of course, the types change based on what the function types are, but this is roughly what it looks like. So how do we actually get that? Because we don't just want to invoke the C functions, we also want to make the function nice to use for normal C# users, right? So first of all, the first step always is to understand what method we really want to generate right now, because SilkTouch doesn't really know about C or C++. It only knows about the function it's given. And this, for example, can be something like a normal function with two parameters, an int and an int pointer, and then it doesn't really do anything because neither of those require any changes to be understandable for C. But for many C# types, we need to do some sort of transformation to translate into C or C++. So for example, if you take a normal array, which pretty much every C# user should know, that's, as you might know, a managed type. So the garbage collector keeps track of it, and C doesn't have a concept like that. So to pass the array to C, we need to transform it into a pointer. And there's two kind of steps to it. First of all, we need to actually get the pointer, and then we also need to tell the garbage collector that it can't move around this array anymore for the duration of the call. So usually it likes to do this, but of course, when we have a pointer to it and we've given this to the C side, that's not possible anymore, because otherwise the pointer would become invalid. And then we, of course, the functions we call into, we cache them, because while loading is relatively cheap, it's not free, so the caching is kind of a little bit of optimization. And last, we take great care in SilkTouch to optimize the function body we generate. It's not really that important to us how optimized the generator itself is, because that only really influences build times. But it's very important that the method bodies, the code it outputs, is highly optimized. So I will quickly move over into C-line here, because I've prepared a little bit of a demo. And then first of all, I want to quickly show the C code. I'm not a C expert myself, but I managed to make this, and it's a very simple method really. We just take two parameters, like I've shown you, with an int parameter and an int pointer, and we just print something and calculate the sum of all the values we're given. So very simple, and I've already built this and copied it over, so we can now invoke it from C#. And that looks something like this. And this is really what all of Silk.net pretty much consists of. And for example, here I've called this sum API, because we take sums of numbers. And if you use, for example, OpenGL, this class might be called GL, or for Vulkan, this may be called VK. But really, they all look something like this. They all have this method, which you would use to actually use it, and then they have lots and lots of these definitions down here. And essentially what we say here, this is what SilkTouch will interpret, and I'll show you what it does in 1 second. We basically have this attribute which SilkTouch picks up on, and you might already notice this is exactly the function name we've just given in C. And this maps one-to-one to the DLL exported functions, and then we can pretty much give this any name, but here I've just chosen to keep it the same. And then the parameters is what SilkTouch tries to figure out. For this, I've made 2 overloads here, and the first one is pretty much just the direct C version where we need to pass a pointer, and some C# people will probably be okay with this and will know how to do this. But for the people that don't want to deal with this, we also provide overloads like this one, and in actual Silk.net code, we provide many, many more. And I've prepared a little bit of a demo application here. That's unfortunate. Apparently it doesn't work to function right now, but okay. So essentially we just get the API call here, and we call the sum function here. And we've already used the overload for arrays here. The actual function uses span. That's why Ryder shows this handy little icon that then implicit conversion happens here. But I think this is pretty idiomatic C# code, just passing an array. That shouldn't be really anything difficult. And I'll just show what this looks like by going to the debugger here and stepping into this function. Just need to change my target, sorry. So we just hit this line, and I'll just step into there. Like this. And this is exactly the code. This was just generated in a couple of milliseconds. You just saw the console do things. SilkTouch was invoked and looked at these parameters and tried to figure out what to do with this. And pretty much what I just mentioned is what we need to do is we need to get a pointer, and we need to tell the garbage collector to not move this around. C# actually has a handy feature for this, the fix keyword, which does both of those in kind of one little task. And sorry. And we just do this here to convert into a pointer, and then we have the pointer, which we can give to C like this. And that's what we do here then. We just invoke the C function like this. Pretty simple, just pass both parameters. And you will notice here at the start, we have a bunch of code that sort of tries to do this cleanly, but it still is very long code. We just have the function point at the start, and then our little bit of our cache mechanism. This is simply cache. I won't really go into detail how this works. And that's really all that SilkTouch does. But it does this thousands of times for all of Silk.net's functions, and will figure out even things like string marshalling, which is much more complicated because C# strings are very, very different from the different kinds of C strings there are. I just quickly...
One thing, and you might remember that was also my initial question, my very first question when I saw what you're doing there, and we also have it in chat, of course. And the question is, how on earth did you start learning all this? You know, like particularly this delegate, pointer, unmanaged, etc. Like how on earth did you learn about this?
I'm honestly not very sure. It's mostly looking at discussions of, for example, the runtime team. They just made this, for example, this function pointer feature. They just made this. So this is a C#9 feature, and I kind of only know about it because I kept track of some of the language discussions.
So basically, C# language repository where all of these suggestions arrive. This is where you read about it and then just catch it up, basically.
Exactly, and I know, like, for example, via the C# Discord, which I also learned about Dylan this way and about Silk.net. there's a lot of awesome people there that seem to just know this, because some of them are part of the runtime team, or also just sit there and kind of look at all of these things. And so it's pretty much just I'm pretty much just standing on the shoulders of giants here, which I've kind of asked and learned about these things from.
Okay, very cool. There was also another question. I think it might fit in here. When is it C and when is it C++?
For us, it doesn't really matter. I kind of use them interchangeably here. It could also be something like Rust. But I think CD and C++ is most common for our kind of libraries for graphics and compute. But for us, it really doesn't matter. You could even, any language that can produce dynamically linked libraries and can export symbols, we can bind to.
Okay, sounds good.
Awesome. So I'll just quickly let the program finish here. And we can kind of see the expected result here, which is the native side saying hello and then our result. Now, one thing I did intend to show differently, but I'm just going to quickly show it like this. Matthias helped us with this, and we now have this, well, it's work in progress, but we have this analyzer now. So if you were to not know about the features that SilkTouch has, you might write code something like this. This is really kind of standard code. You will often see something like this when you work with other bindings libraries. And it'll look something like this. You'll need the unset keyword because we use a pointer, and you'll kind of need to pass the pointer manually here. And this is really, if you've ever worked with bindings or maybe even with pinvoke has some of these features, but not all of them. You will have written code something like this. And using the analyzer we have now, we get this little yellow background here telling us something is wrong. And yeah, it already said there, unnecessary explicit pinning. And it also provides a quick fix here, so we can just apply that. And this is essentially the code we just had. And we can kind of simplify, and then we get this very idiomatic code. So that's kind of a neat feature. We're still working on making this available for all of our overloads, but this is kind of a quick peek into it. I don't know what I'm sure.
That's maybe something I want to climb in very quickly. So I have to say, and like I said initially, this was more or less part of what we're trying to achieve with projects, trying to support them, implementing plugins, for instance, and analyzers. And I have to say, from my personal experience with that, it was really cool to first time writing an analyzer or inspection with unsafe code. So it was surprisingly easy, I have to say. And also it was interesting because it was more or less hacked together a bit. So we definitely have to say this is, and you did already, it's work in progress. And there's a lot more work that we can do, but I think it's a good start. And I was really surprised because I just pushed this yesterday for you to test, and you just picked it up like that and made some changes already. And I was like really impressed. So before you only had experience with the Roslyn API, right? But coming to ReSharper SDK, how was that initial experience for you?
Very good. I knew the Roslyn API well from SilkTouch. We have to work with like pointers and stuff from the Roslyn API there all the time, and the Roslyn the ReSharper SDK is somewhat similar. It's actually quite similar in terms of like API service, but it's just a bit more friendly, I could say. So that was really nice, especially. I kind of made some changes. For example, in the version you posted, instead of passing the array directly, I believe you used another overload, which was something like this. And this isn't working because my demo doesn't have this overload. But just to quickly show that. And really, I was super surprised. This is a pretty big change for example, if I was to do something like this in SilkTouch, changing something like this to something like this would be a relatively big change, just because the Roslyn API isn't really, it's not really meant to build large code blocks, but I feel like the ReSharper SDK does a great job at this.
And I guess if you know one of these two, and I can tell this from my own experience, so I'm mainly in the ReSharper SDK. Picking up Roslyn was pretty easy, and vice versa, obviously the same. So since they're both built on all this syntax traversal, etc., I think everyone will know how to handle things.
Yeah, I think I had absolutely no problem understanding your code there, especially because they use similar terminology and things like that. So yeah, that was really, really nice. So any more questions, or should I move on?
Sure.
Okay, so we have these OpenGL tutorials. I'm not an OpenGL expert, but that's probably kind of the point here. Because this is another feature, we kind of, this was, I think, the very first idea we kind of had when we talked to Matthias about making a plugin, because we knew from other functions. I personally use this a lot for system inbuilt functions. You can just press F1 and it'll kind of take you to the browser and show you the documentation. And this was the very first thing I think I brought up when we talked about what we could do for Silk.net. And I don't really know any GL, but for example, if I was to review this code now and wanted to find out what this attach shader function does, I could just press Ctrl+A and show documentation. Keep you pop up.
It should be open documentation.
Oh yeah, sorry.
Ah, there is it. Yeah.
I also bound this to the F1 key, but I didn't. I didn't want to use this. I wanted to show this menu because, yeah. And if I press Enter here, I will be taken to the browser for GL attach shader. This is from the official OpenGL reference, and I could read this now and figure out what exactly this does, and I can pretty much do the same. For example, this one, pressing F1 here, the same thing, just taking to the documentation, and yeah. So I think this is a really handy feature, which makes graphics very much easier because from my experience learning graphics, you start picking up the concept relatively quickly, and then eventually just becomes a task of finding out things via the documentation, and so this is really helpful.
And I will add something. So because I also everywhere I try to announce like may contain bits of Roslyn and ReSharper SDK. So if anyone is interested how this actually works, like Kai and Dylan, they added an attribute to all these APIs, which basically hold a reference to a key, and that key is then used inside the plugin to match it against the just simple dictionary, and then it will just open that URI in your browser. So if you try doing something something similar, this plugin will also be open source. So you may keep an eye out for that.
Yeah, exactly. So I'm going to go back to the presentation here, and I believe, yeah, Dylan will continue explaining BuildTools here.
Awesome. Yeah. Yeah, this is my generator now. It might not be as cool as SilkTouch. Just to chime in there, that's the first time I've seen the F1 documentation functionality in action. So I'm glad that works. So yeah, that's really cool to see that in action, and I think that will be really helpful for users who are using Silk.net. Because Kai, as you said, you've got to go into the specification to find out specifics, what this function will do. and without reading through a 100-page PDF or having to Google your way, it's a lot faster, and I think it will make our users a lot more productive when they're just starting out. But enough of that, I think. Let's move on to my generator, which is BuildTools. So BuildTools is responsible for taking something that represents a C function, so that could be a C or C++ header, or now the Cronus group are very kind to us, and they give us XML files to describe their APIs, which are a lot more parsable. And then what we do is we take that data, we create a project and data model from it, so we can just figure out what functions which and what each of the parameters are. For example, we'll touch on this in a bit. Then we bake it together, which again I'll talk about it when we get to that stage. We're going to go through each of the stages in detail. And then we sort of add our special sauce to it, so that in that case it's our overloads, and then we just write it to disk, so we can pass it to the next stage, which is SilkTouch, and then obviously the C# compiler. So yeah, moving on, this is what, so we're going to focus only on XML on this because frankly it's easier, and it's easier to describe how it's parsed. So this is an example of the sort of thing we get from Cronus in their XML document. You can kind of see there's something in there that remotely resembles a C function, but it's still pretty C-like. So the next step of this is taking that data and putting together an object model so we can actually understand this. Next slide, please. So yeah, this next step is just putting an object model together so we can understand it and start to bring it less from C and put it more in C++ in C#. So we're in a better stage for the later parts of the pipeline. But the thing is, what this does is it reads every single version of OpenGL has its own feature block, and it treats a feature block as an individual profile, which isn't really ideal considering we don't want to ship 1 million packages for the different versions of OpenGL, because, well, we've got a lot of packages as it is, and I don't think that would do anything to help the situation. So for the next step, what we do is, well, we call this the baking stage, which is where we take the object model we've gathered and sort of identify what to do with it, how to combine it, with the goal of this stage being to just have one big profile, or as it will be output in the C# stages, one big project. So yeah, the problem with this stage is we need to check that there are no duplicate functions in each of the profiles or duplicate enums. If there are, we need to figure out what to do with it, like, are these the same name? Do they have a different value? Do we need to cry? Because that happens if there's discrepancies between different versions. We don't know what to do with it. So this stage has a lot of checking for that. Then we need to filter out any functions or deprecated or we just don't care about, because we don't like supporting the obsolete functions. We do have a separate project for it which does have them in, which we configure BuildTools not to filter those out. But for the mainline project, we don't want to be supporting those old functions, and thus we filter them out. So that's another layer of checking that we add in. And then the final stage of the baking step is, obviously, as you can see that in the previous slides, that was all those types were very C-like. Then they don't look C# at all. Which part of this stage is making the object model represent more C#-like types, and just generally roughly resemble something we can output in the later stages. But yeah, it's very time consuming because of all the layers of checks and all the different all the different loops over the object model that it has to do. It's by far the longest stage of the pipeline. But moving on to the interesting bit, the overloading, which is sort of our special sauce with our bindings, is making the C binding, which are all horrible with pointers, and we lift them up a level to the C# to make them more C# like. So as you can see on screen, I've added a description of some of our most common overloaders. There are more, but they're more specialized with certain graphics APIs, so that we have a lot of OpenGL specific overloaders, which we tailor to make your experience with our OpenGL bindings a lot easier and just generally a lot better to interact with, which is the whole purpose of this stage, is making our bindings a lot more easier to use in a C# environment, because that's a pretty tricky thing to do with a C library. So yeah, and it's recursive as well. So we understand that sometimes you want to use a pointer, sometimes you want to use a span, sometimes you want to use a ref. That's fine. We'll recursively generate all the combinations which could possibly be useful to you. But because of that, it's very time consuming. So we take this penalty when we're regenerating the bindings every month to benefit the bindings with lots of combinations of overloads. So hopefully whatever you throw at it, as long as it's valid in that context, it will work. So yeah, and now next is the final stage. This is actually writing the C# code. I haven't put a lot of description here, but you can kind of see how we've started with this XML document, which is very C-like and has a lot of metadata. And what we've done is we've generated our partial methods, which you may have saw from Kai's SilkTouch section, which are ready to be written to the disk and then be read by SilkTouch and passed along to the Roslyn compiler. Which, yeah, that's the cherry on top. That's all finished now. So if we go on to the next slide, we can see that well, as we touched upon at the beginning, this is a massive time saver, because we have, as I said, we've got over 17 bindings at this point, as of the latest version. And if we make one improvement in one area in this generator, it can span across the whole library and make all of our users happier and have a better time using our library, rather than just being focused on one specific section, like or this OpenGL optimization. Of course, as we said right at the beginning, that can make the lines of code change between different versions very big, very fast. But it's an improvement all around. It makes our users a lot happier using the library. And yeah, there's no need to manually review changes in the specs, which, let's be honest, would take ages considering how many changes there are in Vulkan, or not so much OpenGL these days, but Vulkan especially. That's changing all the time, and we really don't want to go through with a comb and pick all of the changes and manually move them into Silk.net. We'd rather just fetch them and automatically pass through all of them. So next up, we're going to talk about the future of Silk.net, because I think this is worth touching upon, because there's a lot changing in the .NET space at the moment, especially with .NET 6, which is personally what I'm very excited about. Is you'll be able to write one assembly and be able to run it on desktop or on your phone, and that's really a lot better than the current solution, which is all fragmented. I'm not going to go over the benefits of .NET 6 because there are lots of other resources of that, but the most valuable thing is writing once and running your code everywhere. It makes Silk.net a lot more portable, which is one of the goals of our high-level utilities, as I mentioned. And it's just a lot more fluid. No one wants to write code specific for each individual platform, let alone make lots of other projects. But the ability to just have just one project to run on any platform you want to run on, that's a benefit in itself. You don't have to write a lot. But one thing we also want to focus on is better IDE support, because let's be honest, we have a lot going on and not a lot of documentation for it. And so also we have a lot of overloads and a lot of documentation for it. So one of the things we want to do is push our users in the right direction in how to use our library in the most productive way and the most fluid way as well, which is what we're doing with this Rider and Resharper plugin. Is hopefully we can start giving you hints, or this could be more optimized, or this could look nicer, and ultimately that just makes your code cleaner, makes you more productive, which is one of the things we're after with in Silk.net's short and long-term future. But also touching on documentation is that we need to we need to bring up our documentation a tad. This plugin helps with that in that you can just press a key and jump to the documentation we get from our various vendors of the libraries. But also we want to align our documentation and resources with some fabled OpenGL resources or some Vulkan tutorials. It's that we want to have, yeah, documentation is nice, but walkthroughs and tutorials are even better, and that's one of the things we're doing with our examples, is that we're aligning with our OpenGL examples with Learn OpenGL, which is like the #1 resource for learning OpenGL, and to be able to use the concepts you learn from the original Learn OpenGL, as well as see what it looks like in Silk.net, rather than having to sort of make guesswork in porting the tutorials yourself to work in a C# context. That's a lot better, and we think it will be a lot more helpful. But also one of the things we want is project templates, so you can just do .NET new OpenGL, and there you have the bare bones of an OpenGL project. Obviously that's only beneficial at the start of your project, but it makes it a hell of a lot easier, not having to go out of your way to install the right packages and whatnot. It's all just there for you, ready to start hacking at. And there's a lot of other stretch goals as well that this was just mostly me spitballing, is that we want to support WebAssembly, which I know Kai is currently investigating and being driven a bit mad by, with WebAssembly and Blazor. And then maybe in the future we also want to support a couple of consoles as well, like Xbox and wherever else you play your favorite games. Ultimately, it's this concept of bringing high-speed graphics and compute to any platform you could want to do it. So we know we've got Stride looking to port to Silk.net, which is a massive game engine that is full-featured as it is, which we're really excited about. But Stride will be able to use Silk.net to run on any platform that we support. So and only need to maintain one code base, which is really beneficial. And if we can expand that, yeah, it will be really good. And we're really looking forward to the both the short term with the open source Power-Up and the long term of future of Silk.net. And I think that's us about done. Are there any other questions that have popped through in the chat?
Yeah, a couple. I will start with my own question, actually. I'm not sure if you have actually mentioned it during the presentation, because I'm also hopping between different streams here. But how long does the generation with the source generator take?
It depends. So on my machine, okay, should I just answer, or I guess I can just go. On my machine, it goes relatively quickly. Only like 10 seconds or so, but my machine is also quite powerful. On GitHub Actions, where we do the monthly release builds and also PR builds and stuff, it takes about 15 minutes. So, but that's also for like all of our bindings. So like 15 minutes for like
7 million, or what was the number?
Yeah, exactly. So generated by SilkTouch is like 5.5 million, and 15 minutes of like a single core virtual machine is still fine in my opinion.
Yeah, sounds good. Yes, and I kind of have to see where the questions are here. There was one more.
Just to chime in there is the BuildTools section. That's not part of that 15 minutes. Is the BuildTools section only takes 5 minutes, but its own thing. It's not integrated into the compiler like SilkTouch is. Probably for the best. But yeah, it's because we only run that once a month, whereas SilkTouch we run that every compile to make sure that nothing's changed. Because we also have manually written bindings as well as ones generated by BuildTools. So that takes 5 minutes, but there's a lot that goes on in that 5 minutes that just wouldn't work well in the compiler context. Sorry to cut you off there.
Okay, cool, thanks. And yes, there was another question, and it was, so could this, and this was referring to code generation from XML's specifications, work as a source generator in Roslyn, just drop my file and generate on the fly. But that was, I think, around the lines that you just said, right?
Well, theoretically, yes. But the thing with BuildTools is it's currently very specific to our needs, so we do want to change that and make it more generalized so anyone can make their Silk.net style bindings and use any libraries, not just the one we provide in C#. And yeah, it could work in a source generator context, but given how much happens behind the scenes, I'm not sure it would be the best idea, and it's not something we're personally investigating at the moment. But it does bring up an interesting idea, is that if you brought that sort of power where you could just drop in an XML file or even a C header and say, hey, generate this, and just like that you have C# APIs available to you. That would be really beneficial, and we would, that would just make everything easier. But it's not something we're investigating right now because we're not quite there yet. There's still a lot that happens behind the scenes, and there's a lot we'd have to focus on in optimizing.
If I may just chime in there on source generators, one of the big problems for us and for I think many source generator users is that this is kind of the initial version of source generators the Roslyn team has built, and I've talked lots to like people at the Roslyn team about this, and one of the problems is that it's not quite clear what's going to happen with source generators because sort of the tooling is sort of behind. Both Rider and Visual Studio have gotten the feature of stepping into the code recently, really. But for example, initially there was talk about source generators being invoked on every button press, which for example was always this lingering fear, or is always this lingering fear for Silk.net, because if one button press takes 15 minutes, then that wouldn't be so good. So that's also kind of a concern with moving more of our stuff to source generators.
I think if I remember correctly, but don't quote me on that, but one of our developers said it's like 60 times while you're typing console.writeLine, source generators are invoked. So yeah, probably not a good idea to sneak into that, right? There was a second question. Let me find it. And it was, yeah, here. Would it be possible to use it on any C++ library? Yeah, I think that was kind of in that answer from Dylan, right?
Yeah, so yeah, pretty much is we've made some bindings recently that have nothing to do with open. Well, I say nothing. It's still tangentially related because it's still Silk.net, but we've generated bindings that are completely separate from OpenGL that are just provided as C headers, and yeah, we were able to throw them at BuildTools and output bindings. I think the Open Asset Importer was our best example of that, or ASIMP as they like to call themselves. It is that, yeah, we just threw those headers at BuildTools, and with enough battling with just various tweaks in the configuration, yeah, it output nice bindings. So yeah, you could theoretically throw any C header with it, and as long as we support the stuff in there, like it's not too macro crazy, or also it does some other wacky C stuff that we don't even want to begin to support because that's just a maintenance nightmare. Yeah, you could just chuck anything at it and it generate bindings. Yeah.
Okay, cool. And last question, I think, is does the future include a higher level wrapper, or does it aim to be low level only? So any plans for a higher wrapper API?
So not really. So we're specifically not looking at really making something like a game engine or anything like that. We are, of course, looking at improving our input and our windowing code, but we really try to stay with bindings. One thing we do look at for kind of the next major version is providing controls for popular UI frameworks. This is very much just in the talks, so I can't really guarantee this is going to happen. But for example, you could just have like a VPF control or an Avalonia control, and you can just write GL or Vulkan code maybe even in there, and it'll just display that. So that's probably kind of the highest we want to go.
Okay, sounds really cool. I have to say I'm really looking forward to this. Like all the ideas that you have for the future sound really interesting, including WebAssembly, of course, and now when you say Avalonia. We had those two guys very recently on the in the webinar too. So really cool to see how different projects join forces or can be made can be combined in such a great way. I think this is it. Let me just quickly remove Kai's screen for a moment. I have to tell you, that was really interesting. I hope everyone who attended this webinar thinks the same. Actually, I'm sure. This was cool to see source generators being used to such an extent with those 7 million lines, or what the number was. I don't remember exactly.
It's it's like 5.5 million that our source generator generates. The Roslyn developers hate us. They do not condone this sort of use of source generators, and we are looking at they're looking at improving as well as us. So yeah, it's a lot. It's a massive extent. You're right.
See, there are still some questions popping in. So for one, I think I might have said that on the different channel. Is the SilkWriter plugin available already? Not yet. I guess we will still take some time together working on it. I will also invite both of you to our plugin writers channel at JetBrains. And in any case, if someone is interested and you plan to write your own plugin, just let me know. We can work this out. So I guess that will still take a while to finish, but I think it's in a good early stage. There are a couple of things that for the initial draft we just assumed, like for instance, currently it only works with the OpenGL bindings, which is basically just to check which NuGet package you have referenced. So to also make it work with Vulkan, etc. Other questions we had. Okay, yeah, just wanted to say thank you for your work, Dylan and Kai, someone just mentioned. Any plans for audio library bindings that aren't OpenAL?
Ooh, interesting one. So we've actually got X Audio in as well, which is somewhat lesser known, but it's DirectX's equivalent of OpenAL. I think it's a bit more low level as well, but we're also looking at some stuff like Pulse Audio too, and like maybe Fmod, which I know is popular with a lot of game engine developers and a lot of game developers. So it's a case of we're looking at it, and if you're interested in that sort of thing, let us know so we can take that into consideration, because really this upcoming major release is our best opportunity to add lots of features like that. And if this is something you're interested in, just let us know. We've got a Discord server, which we link to in our project README. And yeah, come talk to us and tell us that that's the sort of stuff you're interested in.
Yeah, actually, the next question kind of fits in well here. How open is the project to more contributors? You just mentioned the Discord server.
Oh,
Do
very
you
open.
have, do you have any? Sorry. Do you have any open issues? You let's say like first starters or something? Is there something like that?
Yeah, so there's always the fact that it's such a daunting code base. I mean, it's very hard to sort of throw yourself into it and know your way around. But at the same time, that's why we have channels in the Discord server, is so that you can talk to us and say, hey, I'm trying to do this, but I don't know what this does. Is that we're right on hand most of the time, unless we're sleeping, to answer any question you have about the code base, or heck, even using Silk.net, not even necessarily contributing. And we always welcome new contributors. So everything's open on GitHub, and we're in our Discord server for an embarrassing amount of time. So come drop us a line if you're interested, and yeah, we can help you work through our code base, which we know more than anyone that is very daunting and has a lot of wibbly wobbly segments of it.
Yeah, one thing I wanted to quickly say here is we're currently we're in the process of starting 3.0 development, which is the next breaking release, which will probably come out like later this year or maybe at the start of next year or so. And so if you want to help out or even have some ideas that you want to tell us about, please do so. We can kind of fit them in right now or like in the next bit of time. If you show up in like February, when we just released the breaking release, we can't do much more than kind of write it down for the next one. So if you have any ideas, please tell us about them.
I hear breaking change. But yeah, again, I have to say that was really interesting with both of you. I'm very proud to have you had here. That was cool. So for the closing notes, let me just say a few things. So if you need more information, here are a couple of links that you can follow, like following us with Ryder on Twitter. Also our recordings will be available at JetBrains TV, but also for .NET Foundation, I think I should update that from here on moving forward. They should be available there as well. We also have a blog, including all my teammates. You can go check out Dylan and Kai on GitHub, and of course Silk.net if you like that. One more thing I want to say here, and this is again very at my heart here. So in the name of all the precious open source projects that we have, and also looking at these sustainability issues that are out there, try to make a difference at your company. Both of them just mention a couple of ways how you can also get involved. I'm sure they would appreciate that. And so try to push this idea of caring for what you depend on. This is what this format is about, and may it be through money, what you can spend, or contributions, like I said. So I think everything here will be highly appreciated, and also not just Silk.net, of course, but all the projects that you know and you depend on. And with that said, just again, thanks for joining. Thanks you two. It was a real pleasure to have you here. And for everyone watching, if you like this format, like and subscribe, both .NET Foundation and JetBrains TV, if you're up for it. And yeah, thanks again, and see you hopefully. I can say already next time we will have SpecFlow here with one of their maintainers and community managers. That will be interesting too. I think it's on the 8th of June, I think, or 7th. Keep an eye out on our Twitter account. And yeah, thanks again, and see you next time.
Cheers.